Good morning, students. Today we will start with new unit number 3, and in this the topic to be covered is first order ordinary differential equations. First order ordinary differential equations. And here we will study exact differential equations. Exact differential equations. Now the standard form of first order differential equation is dy over dx equal to some function of x comma y, and it can be written in the form m x comma y dx plus another function of xy dy equal to 0. Now this equation, it is said to be this differential equation is said to be an exact differential equation if m dx plus n dy, it can be written as d of some another function of u, where u is a function of variables x and y. And the most important theorem related to this topic is the necessary and sufficient condition for the differential equation to be exact. The necessary and sufficient conditions for the differential equation m dx plus n dy equal to 0. Now here, if m dx plus n dy equal to 0 is a given differential equation, with the condition that m n partial derivative of m with respect to y, partial derivative of m with respect to x are continuous functions of x comma y, then m dx plus n dy equal to 0 is exact, then m dx plus n dy equal to exact if and only if curly m over curly y is equal to curly n over curly x. Now in the questions, first of all we will check whether the differential equation is exact or not, and then we will find its solution. And in case and if one is exact, then solution of 1 will be given by Then solution of 1 will be given by integral m dx taking y as a constant plus integral terms in n not containing not containing x dy equal to some constant c. How we will solve the sums? First step is to write the given differential equation in this form, that is m dx plus n dy equal to 0. Then we will evaluate curly m over curly y and curly n over curly x. In case both of these are equal, then we will say that equation 1 is an exact differential equation, and if it is exact, then solution is given by integration m dx taking y as constant plus integral terms in n not containing x dy equal to c. Now we will solve some questions based on this. First question, solve the differential equation. Solve the differential equation 2x into sine 3y dy plus 3x square cos 3y dy equal to 0. Now first of all, I will compare the given differential equation with m dx plus n dy equal to 0. Compare the given differential equation. Compare the given differential equation with m dx plus n dy equal to 0. We get, sorry, here it is dx. We get this equal to m and this equal to n. We get m equal to 2x sine 3y and n equal to 3x square cos 3y. Now we will evaluate curly m over curly y, curly m over curly y. That means partial derivative of m with respect to y. In that case, 2x is constant. Partial derivative of sine y with respect to y is cos of 3y into derivative of 3y with respect to y, it is 3, or it is equal to 3 to the 6x cos 3y, and curly n over curly x, 3 constant, derivative of x square 2x cos 3y as it is, or this is equal to 6x cos 3y. Now therefore curly m over curly y is equal to curly n over curly x. Therefore curly m over curly y is equal to curly n over curly x. Therefore given differential equation is exact, and thus its solution is integral m dx taking y as constant plus integral terms in n not containing x dy equal to c. Now integral m is this 2x sine 3y taking y as constant dx. Now plus terms in n not containing x. We have to choose only those terms from n which do not contain x. Now n has only one term, this total term, and it contains x. That means it has no term which does not contain x. That means here I will get 0 equal to c. Now here as y is constant, 2 is constant, this implies that 2 sine 3y integration of x dx is c. Now one thing more, like in derivative the result was x power n, derivative of x power n is n x power n minus 1. Now integration means what is a function whose derivative is this, or you can directly apply the formula integration of x power n dx. It is x power n plus 1 divided by n plus 1 plus constant of integration c. That means in integration we will increase the power by 1 and divide by this increased power, or this implies that 2 sine 3y integration of x will be x meaning x power 1 x square by 2. As in the right hand side I have already added c plus some another constant, it becomes some another constant, or this implies 2 will be cancelled out, x square into sine 3y equal to c, and this is a required result. Now next question. Solve x dx plus y dy equal to a square x dy minus y dx divided by x square plus y square. Now it can be written as x dx plus y dy equal to a square x divided by x square plus y square dy minus a square y divided by x square plus y square dx, or this implies that now I will combine the like terms, x minus minus plus a square y divided by x square plus y square dx plus y minus a square x divided by x square plus y square dy equal to 0. Now compare equation 1 with m dx plus m dy equal to 0. We get m equal to x plus a square y divided by x square plus y square, and n equal to y minus a square x divided by x square plus y square. Now we have to evaluate curly m over curly y and curly n over curly x. Now curly m over curly y, x is constant, its derivative is 0. I take a square outside. Now for derivative I will apply u over v, x square plus y square whole square, denominator as it is, partial derivative of numerator with respect to y of numerator, that is y, minus numerator as it is, partial derivative with respect to y is y of denominator. Here I have applied the formula, that is if y equal to u over v, then dy over dx, this is equal to v square, v as it is, derivative of numerator minus numerator as it is, derivative with respect to x of denominator. How is the formula? If y is u over v, then to find its derivative, in the numerator I will write v square, in the denominator I will write v square, and in the denominator first of all as it is, derivative of numerator minus numerator as it is, derivative of denominator. Now here I am dealing with partial derivative. just only one difference. A square divided by x square plus y square whole square, x square plus y square, partial derivative of y with respect to y 1 minus y as it is. Now when I take partial derivative with respect to y, in that case other variable will be constant, that is here x square is constant. Derivative of x square, that means constant, is 0, and partial derivative with respect to y of y square is 2y, or this is equal to a square x square plus y square minus 2y square divided by x square plus y square whole square, or this is equal to a square x square y square minus 2y square, it gives you minus y square divided by x square plus y square whole square. Now call it number 2. This is curly n over curly y. Now I will find partial derivative of n with respect to x. Now n is y minus a square x divided by x square plus y square. This implies that curly n over curly x. That means I have to find partial derivative of n with respect to x. Therefore y is constant, its derivative 0. Constant a square outside. This formula, denominator whole square, x square plus y square whole square, denominator as it is, partial derivative of numerator with respect to x, minus numerator as it is, partial derivative with respect to x of denominator, that means denominator when I say this denominator, or not this, equal to minus x square minus a square x square plus y square, partial derivative of x with respect to x is 1 minus x. Now partial derivative of x square with respect to x is 2x plus partial derivative of y square with respect to x, it is 0, divided by x square plus y square whole square, or this is equal to minus a square x square plus y square minus 2x square divided by x square plus y square whole square, or this is equal to minus a square x square minus 2x square, it becomes minus x square plus y square divided by x square plus y square whole square. Now take this negative side inside, a square x square minus y square divided by x square plus y square whole square. Let it be number 3. This is curly n by curly x. Now curly m over curly y, it is a square x square minus y square over x square plus y square whole square, and same is a curly n over curly x. Therefore from 2 and 3 we get partial derivative of n with respect to y is equal to partial derivative of n with respect to x. Therefore given differential equation is exact, and hence its solution is given by, what was that, integral m dx taking y as constant plus integral terms in n not containing x dy equal to c, or therefore it is equal to, or this implies that this was the equation, this. Now I will write integral integral y constant m is this total x plus a square y divided by x square plus y square dx plus terms in n not containing x. Now this is n, it has two terms, one is this and one is this. Now I have to choose only that term which does not contain x, therefore it is only y because it contains x, plus y dy equal to c. Or this implies that integration x dx. Now here y is constant, a square y outside, integral 1 over, I write it as y square plus x square dy, and here y is constant plus integration of y dy equal to c. Now write some formula. Integration of x dx, it is x power 2 over 2 plus c, and integration of 1 over a square plus x square dx, where a is constant, then its formula is 1 over a tan inverse x over a plus c. Now here as y is constant, it is like a. Now integration of x is x square over 2 plus a square y as it is. Integration of this is 1 over a meaning y, 1 over y tangent inverse tan inverse x over y plus y square over 2 equal to c. Now all of the constants are compensated over the right hand side. Or this implies that x square over 2 plus these y's will be cancelled out, a square tangent inverse x over y plus y square over 2 equal to c. Now take 2 LCM, x square plus 2a square tangent inverse x over y plus y square equal to 2c. Or this can be written as x square plus y square plus 2a square tangent inverse x over y equal to a, where a is another constant which is equal to 2c. Now next sum, this is typical one. Solve 1 plus e raised to power x over y dx plus e power x over y 1 minus x over y dy equal to 0. Now compare 1 with m dx plus n dy equal to 0. We get m equal to 1 plus e power x over y and n equal to e raised to power x over y into 1 minus x over y. Now we have to find partial derivative of m with respect to y. One is constants, its derivative 0. For e power x over y, e power x over y into partial derivative of this power, that is partial derivative with respect to y of x over y. Or this is equal to e raised to power x over y. X is constant, I take it outside. Partial derivative with respect to y of 1 over y meaning y power minus 1 equal to e raised to power x over y. X for derivative I take power as multiplication into power reduced by 1, that is minus 1 minus 1. Or this implies that curly m over curly y equal to minus x, y power minus 2 meaning minus x over y square into e raised to power x over y. How is this? E power x over y as it is, x minus y power minus 2 becomes 1 over y power 2. Now we will evaluate partial derivative of n with respect to x. Now n is e power x over y, 1 minus x over y, and we have to evaluate partial derivative of n with respect to x. Now both of these are functions of x, therefore I will apply the formula u into v. That means if you have to find derivative with respect to x of u into v, this is u as it is v dash plus v as it is u dash. Dash stands for derivative. That means first of all I will write u as it is, then take the derivative of v plus v into derivative of u with respect to x. Likewise here e power x over y as it is, here is a partial derivative. Partial derivative with respect to x of 1 minus x over y plus 1 minus x over y as it is into partial derivative with respect to x of e power x over y, or this is equal to e raised to power x over y. Now 1 is derivative of 1 is 0, 1 over y constant as it is, derivative of x is 1 plus 1 minus x over y, e power x over y as it is into partial derivative with respect to x of x over y equal to minus 1 over y e power x over y plus 1 minus x over y e power x over y. Now here y is constant, I take it outside. Partial derivative with respect to x of x equal to e power x over y, I take it as common, minus 1 over y plus 1 minus x over y into 1 over y, derivative of x with respect to x is 1 equal to, now I repeat it again. To find its partial derivative with respect to x, I apply the formula u into v. Product rule. How is that? First as it is, derivative of this function with respect to x plus, now this as it is, derivative of e power x over y with respect to x equal to e power x over y, derivative of x, या partial derivative of x with respect to x is 0 minus 1 over y is constant, I write it as it is, derivative of x with respect to x is 1 plus 1 minus x over y. Now I write the formulas in the form derivatives. Now if you have e power some function of x, then formula is e power function of x into derivative with respect to x of fx. Likewise here I write e power x over y into partial derivative of this power, e power partial derivative power, that is x over y. Now it is equal to minus 1 over y e power x over y plus 1 minus x over y e power x over y into 1 over y constant outside, partial derivative of x with respect to x, or e power x over y outside minus 1 over y plus 1 minus x over y, 1 over y, partial derivative of x with respect to x is 1, or this is equal to e power x over y minus 1 over y, now open the brackets, 1 over y minus x over y square. These will be cancelled out. From here we get curly n over curly x is minus x over y square e power x over y. Now curly m over curly y, in the previous I have calculated this. Now both are equal, therefore from 2 and 3 we get curly m over curly y is equal to curly n over curly x. Therefore, given differential equation is exact, and hence its solution is given by integral m dx taking y as constant plus integral terms in n not containing x dy equal to c. Now this was the equation. How will write integral y constant, that is integration y constant 1 plus e power x over y dx plus terms in n not containing x. Now both of the terms contain x because this total is multiplied by e power x over y and it contains x. This plus 0 equal to c. Or this implies that now integration of 1 with respect to x, it is x because derivative of x is 1 plus. Now integration of e power x over y with respect to x, it will be e power x over y divided by coefficient of x, that is 1 over y equal to c. Integration of 1 dx, it is x plus c, and integration of e power ax dx, it is e raised power ax divided by a plus c. Now in this case, the point to be noted is that here I have said that if I have e power fx, then its derivative with respect to x will be e power fx into derivative with respect to fx, derivative with respect to x of fx. Now in case of integration, you cannot have here the any other form of function of x. You just only have the derivative, the formula when it is of the form e power a into x. You cannot have here x square, x cube, anything else. Or this implies x plus y e power x over y equal to c, and this is the required result. Now I give you some of the questions in an assignment. The questions are: solve x 1 plus y square dx plus y 1 plus x square dy equal to 0. Second one is x square minus ay dx equal to ax minus y square dy. Third one is x square minus 4xy minus 2y square dx plus y square minus 4xy minus 2x square dy equal to 0. Next, x square plus e power x over y dx plus e power x over y 1 minus x over y dy equal to 0. Next, x dx plus y dy plus x dy minus y dx divided by x square plus y square equal to 0. And last question, dy over dx equal to ax plus hy plus g divided by hx plus by plus f. And I hope that you will be able to solve these questions. Thanks.